This program is presented by the Associated General Contractors of America.
In this industry, some of the most important tools we use are chemicals. From liquids and powders to solids and gases, chemicals help us clean, seal, build, and essentially get the job done right. The trouble is, we get so used to working with these materials, we tend to forget the risks involved. And this can leave us wide open for problems. Many of the materials we use in construction can be hazardous, and so we have to handle them correctly to keep ourselves from getting hurt or sick. That's the purpose of a good hazard communication program. It provides training on how to recognize the risks associated with different materials and how to protect yourself. In other words, it helps you answer three important questions. What am I working with? How can it hurt me? And how do I protect myself? To answer the question, what am I working with? Start with a product label. In this small space, there's a lot of good information that can go a long way in preventing injury and lost time on the job. Written manufacturer's labels list the name of the product, the manufacturer, and possibly the manufacturer's phone number. You'll also find the appropriate hazard warnings, as well as certain safety information, such as how to use the product, how to store it, and what personal protective equipment you'll need. If you see any of these words, caution, warning, and danger, pay special attention. The word danger is particularly important, since it indicates you'll need to take some kind of protective measure right away. Labels may also be color-coded and use numbers or icons to show you there's a hazard or that you need to protect yourself. On these type of labels, the color blue indicates a health hazard, red, flammability, yellow, reactivity, and white for additional information. The numbers inside the colored areas show the degree of danger, 4 being the most hazardous, 0 the least. So a 4 in the red area means the product is highly flammable or explosive. Icons or symbols may also be used to indicate what personal protective equipment should be used. These labels and symbols are like warning signs, letting you know what hazards lie ahead. But for detailed information, look at a Material Safety Data Sheet, or MSDS. It'll tell you everything you need to know about a chemical or a compound. Like a label, the MSDS identifies the material and lists the manufacturer's name and emergency telephone number. In addition, it lists the hazardous ingredients and describes the physical properties of the product, what it smells like and looks like. And MSDS also contains information such as fire and explosion hazard data, health hazard information, emergency and first aid procedures, handling and storage precautions, and recommended personal protective equipment. Contractors are required to keep a list of all chemicals used on a job site, along with the corresponding MSDSs. Where the sheets are located and who's responsible for keeping them is covered in your company's written hazard communication program. This is available for your review. Ask your supervisor if you have any questions. Labels and MSDSs are a great place to find product information, but you should also know what hazards to watch out for. The word factor can help you remember these hazards. Factor stands for the 4 major categories of hazardous materials: flammable and corrosive, toxic, or reactive. Paint solvent is an example of a flammable substance, since it can ignite or catch fire easily. Corrosives include the products used to strip floors or clean masonry, the ones that can also damage your eyes or eat away at your skin. Toxic substances can poison you if you breathe them, absorb them through your skin, or accidentally swallow them. Carbon monoxide gas from a forklift engine can be toxic. So can the vapors from solvent-based paints, and you can't even see them. Reactives are substances that can react violently or generate dangerous gases when mixed with other materials. Concentrated sulfuric acid, also known as battery acid, is an example of a reactive material. There's also a good chance that one product may cross over into several categories. For example, a flammable lacquer thinner can also be toxic. So always check the product label and MSDS. Knowing exactly what you're working with is essential in helping you answer the next question. How can it hurt me? In general, we need to protect ourselves from two kinds of hazards: physical hazards and health hazards. Physical hazards occur when materials burn, explode, or react. By affecting your physical surroundings, they can also affect your personal safety. For example, flammables or reactives can start burning or explode if they're mixed with the wrong material or are stored in the wrong place at too high a temperature. Health hazards, on the other hand, include injury to your internal organs, eyes, hearing, or skin. This damage is primarily caused by toxic and/or corrosive materials getting into the body. You might notice these effects right away, or they can take years to appear. The word acute refers to something that affects you right away, like an acid burn or getting dizzy from a cleaning solvent. These warning signs help you recognize the danger involved. Chronic reactions, on the other hand, develop over a period of time. And because the warning signs aren't there, there's a tendency to skip protecting oneself right now. Silica exposure is one example of a chronic health hazard. Workers may be exposed to silica with no immediate visible effects, and then, after years of exposure, may exhibit signs of lung disease. The key to preventing both acute and chronic health hazards is asking, how do I protect myself? In general, your best protection is to avoid getting the material in or on you. It's important to remember that chemicals can be inhaled, swallowed, or absorbed. For example, say you spill a little paint thinner on your skin. No big deal, just wipe it off and it'll dry, right? Well, this may be how you see it, but here's how the chemical sees you. How about that powdered chemical you've been working with? Think that can't get into your body? Think again. You see, it's pretty easy for hazardous materials to enter your body unless you protect yourself. Generally, there are three ways to do this. They include engineering controls, administrative controls, and personal protective equipment. Engineering controls are your first line of defense. This means using special equipment or technology to prevent exposure to hazardous material. Some examples of engineering controls include using fans or blowers to provide fresh air ventilation, using wet methods during grinding or sanding to help keep dust out of the air and out of your lungs, and substituting other, less hazardous materials for the chemicals being used. Administrative controls also help you limit your exposure to hazardous materials. You can keep exposure to a minimum by cutting down on how much of the material you're exposed to, or how long you work with the material. How do you know what's considered too long or too much? Experts have determined these limits based on the amount a normal person can safely be exposed to a material for 8 hours a day, 40 hours a week, without long-term health effects. These limits are known as the threshold limit value, or TLV, and the permissible exposure limit, or PEL. You can find these listed on the MSDS. So, your TLV and PEL tell you the maximum concentration of a chemical in the air that you can be exposed to over the course of a workday. How is this measured? Many contractors have equipment available to measure chemical concentrations. Others use insurance company loss control departments, trade groups, or private consultants to measure actual worker exposure. These results, compared to the TLV or PEL, can tell you if conditions are safe or not. Knowing these limits is important, but not enough. It's also essential that you monitor your physical state, since some people are more sensitive to certain materials and could have reactions at lower levels. So if you ever think a chemical is making you feel sick, let your supervisor know immediately. It's also important to limit the number of workers who come into contact with toxic chemicals. Using barricades and the appropriate signs can help keep others away from areas where hazardous materials are being used. Since even the best system isn't fail-safe, it also helps to know the job site emergency plan, as well as where the nearest safety equipment is and how to use it. Using personal protective equipment is the third way to protect yourself. These keep hazardous materials from getting in or on your body. PPE should only be used after engineering or administrative controls are in place and potential exposure still needs to be reduced. Chemical protective gloves and clothing help keep chemicals off your skin so they aren't absorbed into your body. But make sure that the glove or clothing is designed to protect against the chemical you're using. In some cases, using the wrong glove can be worse than using no glove at all. An MSDS, or safety professional, can help you select the equipment that offers the best protection. Eye protection, such as goggles and face shields, help keep hazardous materials off your face and out of your eyes. And when dealing with corrosives, you should never wear contact lenses. They can make it difficult to flush the eyes if a splash occurs. Respirators help prevent vapors and airborne particles from entering the body, as long as you use the right respirator for the job and the equipment is fitted, worn, and cared for properly. Check the MSDS for the recommended type of respirator to wear when using the product. Personal hygiene is also important, as it can help you avoid ingesting hazardous chemicals. Always wash your hands and face before eating, drinking, or smoking, and keep food away from work areas. Remember, you want the pipe dope on the building, not on your sandwich. So, now that you know what to do, let's put it all together and look at an example. Remember, start by asking, what am I working with? In this case, let's say you're going to be working with a solvent. Checking the manufacturer's label and MSDS lets you know exactly what the product is and the hazards involved. Keeping factor in mind, you see that the product is flammable, with vapors that can be toxic. This information helps you answer the question, how can it hurt me? Because flammables can cause physical hazards, such as fires and explosions, you need to make sure to keep sparks and flames away. And since toxins could cause health hazards, you need to prevent the product and vapors from getting in or on you. Think, how do I protect myself? Start with engineering controls. Increase ventilation by using fans and opening windows. These help lower the concentration of vapors and reduce your exposure to the solvent. Know your exposure limits. Remember, the PEL and TLV tell you the maximum concentration of the solvent in the air that you can safely be exposed to. If you feel sick at any time, tell your supervisor. Finally, use the proper PPE, gloves, eye protection, and a respirator. Make sure you're using the right respirator for the job and that it's fitted, worn, and cared for properly. Whenever you can, move the work outside, even if you're just mixing up chemicals or cleaning up. You see, safely handling hazardous materials isn't tough, as long as you stop and think what you're doing. Ask yourself, what am I working with? How can it hurt me? And how do I protect myself? If you're able to recognize the hazards involved and how to protect yourself, this knowledge will go a long way in preventing injury to yourself and everyone around you.